The ACCSEAS multi-source positioning service considers the need for resilient positioning, navigation and timing information and supports the International Maritime Organization's e-navigation concept. By recognizing when the vessel's primary means of navigation fails or becomes unreliable, the service will enable positioning, navigation and timing data from an alternative source, allowing vessels to continue their intended operation. This service will help mariners to navigate in what is becoming an ever-constricting waterway. Most vessels rely on GPS for positioning and navigation data, and when this is lost, the mariner can be subjected to a large number of alarms as their bridge equipment either fails or enters an alarmed state, as can be seen here during an early ACCSEAS trial investigating GPS jamming effects.
As the jamming signal builds up, we'll get more alarms. A couple of alarms that you're kind of normally used to, you can go and deal with. When you start getting a host of alarms going off, what do?
The multi-source positioning service will prevent these alarms and enable the mariner to safely continue their operation without being distracted. The ACCSEAS project has considered how to assess the reliability of the received GPS data. It has investigated a number of alternative positioning systems that can then be used instead of GPS, and how this functionality can be integrated into a ship's bridge. The first alternative system considered is called R-mode, or ranging mode. This is a new position solution developed by the ACCSEAS project. By adding a means of calculating a range to existing maritime radius systems, the mariner should be able to calculate their distance to each transmitter location, and therefore can calculate their position independent to GPS or any other satellite navigation system. A further alternative positioning solution considered was ELORAN. ELORAN is a low-frequency navigation system which meets the IMO performance requirements for port and harbour approach, providing accuracies in the order of 10 metres within major port areas up the east coast of the UK. Having considered the alternative systems which could be used to mitigate any GPS or GNSS outage, the project then considered how any GPS issue would be identified. GPS does not provide any information on its own integrity. Therefore, the project developed software to monitor whether the received GPS position information is within tolerance. Several performance metrics are also monitored, as they too give an indication of poor performance and service degradation. The project contracted the development of an ACCSEAS resilient PNT receiver, capable of taking information from GPS and other positioning systems. Initial development has resulted in a receiver capable of providing GPS and ELORAN positions with the potential to use absolute radar positioning or R-mode positioning information generated elsewhere. Software on the receiver constantly monitors the performance of each available positioning system and selects the one deemed the best for output to the bridge systems. If GPS becomes unreliable, the system would switch to an alternative source. The system would continue to monitor the performance of all sources, and once the issue had passed, it would return to providing GPS data if deemed the best. The mariner is informed of any change of position through data provided to the ship's systems, and a visual change to the LEDs on the receiver case, along with other alerts if required. Awareness of the change is important, as it can lead to a change in navigation safety of the vessel. The multi-source positioning service was tested on board the P&O ferry the Pride of Hull. The demonstration took place as the vessel sailed its normal route from Rotterdam to Hull.
Pride of Hull, beaches, number.
Yeah, good morning, sir. Just to inform you, we have some GPS problem.
Pride of Hull, beaches, number. That's all received. Thank you for ACCSEAS exercise. We are aware of a GPS outage in the area.
The vessel was fitted with a prototype multi-source receiver. The output of the receiver is used to drive the navigation input to the e-navigation prototype display. This enhanced chart plotter plots the position of the vessel on an electronic chart and displays the results of e-navigation services. The PNT data module is used to tell the mariner which system is currently being used to provide the vessel's positioning information. Positioning systems are not perfect, and the receiver can also output an indication of the positioning error, referred to as horizontal protection level. This can be displayed numerically or graphically with an error ellipse overlaid on a scaled image of the vessel. The aim of the demonstration was to illustrate the receiver functioning during a complete failure of GPS. For the purposes of this demonstration, this was performed by disconnecting the GPS antenna from the receiver.
We had a GPS loss. We got a nice warning on the screen saying, okay, you lost your GPS. You switched over to the ELORAN system, and the position stayed the same. You didn't see it flashing on the screen. So I can imagine that a lot of users will have interest in a system like this.
There is no need for user intervention. The switch happens automatically and the vessel is free to continue on its journey, with no intervention by the ship's navigator, who can get on with the important business of navigating the vessel safely towards its destination.